All right. Good afternoon, everybody. In the first video, we were able to analyze, you know, convincingly how to go about the solution of this problem. Okay, and we've gone further to um, problem was write a Python program to compute the root of a quadratic equation given by the formula we have here, and of course we've explained in part 1. So in part 2 we are going to go about implementation of this design. Okay, so we'll proceed to the implementation phase, right? So we'll proceed to the implementation phase. Okay, so implementation, um, we'll proceed to implementation. So what do we say is in implementation? Of course, implementation, uh, implementation. Of course, we said in the implementation phase. Sorry about this. Let's wrap this up. So in the implementation phase, implementation involves the implementation of the design of the designed algorithm. Okay, uh, using a programming language. In this case, we'll be making use of Python. Okay, we'll be making use of Python. Right. Now we are going to jump into our Python IDE. Okay, so let's proceed into our Python IDE. So here, as usual, I have created a document. Remember the last we had practice 1, so this is my practice 2, and of course the name of this the source program file, okay, is what we refer to as roots of equation.py, right? So this is the environment here. Now, so what are we writing about? Okay, very quickly, just come up. So okay, so I wouldn't be making use of the board at this point. I have to. All right, so a program to compute the what? The roots. Okay, the roots of a quadratic equation, right? So the first thing is, of course, prompt user for what? For input, just as we have in our algorithm. We have to prompt. Okay, we have to prompt user for input. Okay, so we have to prompt the user for input. So we are going to be making we are going to be making user we are going to be making reference. Sorry, just a minute. Let me see if we can play around this a little bit. Good. This is what I actually wanted, right? And, okay. Now we are going to work side by side, right, to see from this phase and all of that. Okay, so we've been able to write for a prompt. Okay, right, we're able to prompt. Okay, good. So now the next thing is prompt user for input. Okay, and what are the inputs? We need to input, of course, we need to input ABC, right? So I just need one more of this. It's my input command. Then of course I have to change this to this will be C. Sorry, it has to be lower C. Then of course this is gonna be D term. Then of course this is gonna be an A, right? So of course here we can say input. Let me zoom out now. Input the value of A, right? Then of course here input the value of B. Okay, the value of B. Then the next one is gonna be input the value of C, right? So having gotten here, then the next thing is we've made our input. Okay, we've made our inputs. Then at this point we should be able to proceed. We should be able to proceed to, should be able to proceed on. We should be able to proceed with computing our discriminant, right? So computing the discriminant of the quadratic equation. Of course, the discriminant is, we use D, right? So very quickly, I just need to verify. Yeah, B squared, right? Good. So that's going to be equals to B raised to the power of 2. In Python programming, we use double asterisks to represent raised to the power 4 times A. All right, 4 times A times C, right? 4 times A times C. Okay, 4 B squared minus 4 times A times C, right? Okay, so we have base, right? So okay, so we have base, right? Then of course, now that we have base, we now have our decision 1 and of course decision 2, right? So what was our decisions? Decision that we made was for real and distinct roots. Real and distinct roots. That's when our discriminant, we say, is greater than the value of 0. Then of course the next test is for what? 2 equal what? Roots, right? And right? Yes. And complex roots. Okay. Now number here is going to be D equals 0. Okay. Now, so at this point we are going to use the if else. If, okay, then of course then we now have L if. Okay, we are going to have a video, to explain what, in programming we refer to this as construct, okay, control structures, whereby you have the selection and all of that. Okay, so now if D, okay, is greater than 0, that's going to be the first, and then L if d is equal to 0, okay, then of course at the end of, we will now conclude it else, okay, perform the operation, right? So now we do not have an assigned, we don't have any function here. So what do we do? So here now is going to compute both x1 to be equals to, we said is going to be negative b plus okay, so there might be need for us to import at this point here, just before we start writing the program. At this point we can import math, okay, so that here we now have square root. That's going to be math dot okay, sqrt. I'm going to be back a few minutes. Okay, so we have to, for us to use the square root function, remember at this point we made use of square root. Look at this, square root of d, okay. So for us to be made good to make use of the square root, we have to import we have to import math, okay. Then here we now need to call math.sqrt function, okay. So that's the math.sqrt. So we have to import math library, okay. Then in the math library we now use the dot to pull the square root function, which is sqrt, okay. So how do we go about this? That's going to be, now this is our positive v plus square root of d, so we just pass in d here. That's that about that. Then the next is we proceed, we compute x2. Don't forget x2 is negative b negative math.sqrt d. And so that's that about that. We're done, okay. Now that we're done, we will now come here, else if, now don't forget, whenever you're writing a program in Python, a block of code is depicted by our tab on our keyboard, okay, tab on our keyboard, tab. So you may be wondering, where is tab? Let me show us on screen keyboard. So of course this is your tab function, okay. So whenever you have a cursor here, you need to press this tab, okay, then it's going to create the block of code for you, right? So now the next one is equal root, okay. So equal root is x1, of course. We say negative b divided by what? x2 times a. Now don't mind me, I should have included the whole of these in a bracket, okay. Then of course this is going to be divided by 2 times a, of course. Then same thing applied here, okay. Same thing applied, divided by 2 times a, right? Okay, 2 times a, okay. So we have 2 times a. Then of course at this point our x2 will be x1. So we'll pass in the value of x2, x1 here. So the next thing is, we just simply say print, what do we print? Print, if it is not this condition and this, then it should print that what? It should print that roots are what? Complex. Did we have? Roots are complex, exactly. Roots are complex, okay. The roots are complex. So Now I would like us to, so at this point you should be able to um okay, we are going to see for troubleshoot. um so you see, all right, so um this is the solution we have. Excuse me, this is the solution we have here. So um we have to import math, okay, from the math library. You just say import math, and we need to make use of the function called sqrt, that's square root. Okay, we've made our input, right? Then abc, then we proceed forward to compute the discriminant of the quadratic equation. Then of course this is the computation. Then this is our decisions that had to be made. Okay, then of course we have the different scenarios here, right? But just a quick one. So the conclusion of, so let's quickly look at this code very well. So print complex root. So now mind you, we are outside of this block of code. Okay, so after, if this condition is satisfied, it will compute x1 and x2, and it will display the result here. Okay, now however, if it is equal to, then it will display the result here. Okay, now all right, so this is this line of code here is just to display a prompt. Okay, is to give an example of the quadratic equation, right? So I have a good example of a quadratic equation here that I want to show us just before we proceed to computation, right? So an example of a quadratic equation that I have here is um, x squared minus 5x plus 6 equal to what do you call it now, 0. Now this has the solution of x here. We have 3 and 2 here, right? Then of course we'll have um, um, take it this way, and then we take it this way, right? So that's going to be x minus 3, whichever one, and x minus 2, okay, equals to 0. So we now start see that x is 3, or x can also be 2. So this can be x2 and this is x1. Okay, so we can see that x squared minus 5x plus 6 is equals to 0. It gives us x1 is 3, or x1 can be 2, depending on how you arrange it. X2 can be 3. Okay, right? So these are the solution. Basically it's just 2 and 3 that is the solution. So let's go and test run our program. Now in test running, so I'm just scrolling so that we can get the full code in case we are practicing, right? So this is it here. I'm going to scroll down. This is it. This is it. Make sure you get the code in full. So this is the code here. This is the code block, and let me move. This is it here. Okay, I hope you've taken your time to. So now I want to run it. So when I run it, just run. Then it's asking us to impute the value of a. So what's a? Our a is going to be what? 1. Okay, then minus 5 and what? And 6. How do I know that? If we, by the time we come here, look at it. A is 1, B is minus 5, and C is what? Positive 6. So we are going to have this a. Our a is 1, B is minus 5, then of course negative 5, and C is 6. So when we impute that, uh, we now, so you can see now it has actually brought out the computation for us. So you can see this is 1x squared minus 5 minus 5x is supposed to be x, I think. Okay, let's correct that here. There's not supposed to be a b here. Okay, and there's not supposed to be a c here. I think so. Yeah, so let's rerun it again. 1, negative 5 and 6. So you can see now, so that's going to be 1x squared. Okay, 1x squared. Let's make it to be much more. I can put my caret symbol signifying that it's a squared. Okay, so then we rerun it. So that's 1, sorry, minus 5 and 6. I guess we have something much more better now. Okay, so this is 1x squared minus 5x plus 6, just as we have in this equation here, right? So I guess just as we have here. Okay, so these are the solutions. We got 2 3, so this is 2 3 into two places of decimals. Okay, right. So I believe we have had a nice time writing this program, and I hope we have a wonderful day. What's even the time in Nigeria now? It's just 3:28 in the evening. All right. So I wish us good luck in our studies, good luck in our research, good luck in our life endeavors. Please click like, subscribe, and share. God bless you. Amen.